Hi, today we will learn the application of Laplace transform to linear differential equations, that is transformation of ordinary differential equations. Ordinary differential equations in which total derivatives are involved. The working rule to solve these differential equations: given a differential equation, first we should take the Laplace transform on both sides and apply the initial conditions. That is the first step. In the second step, from the first step, differential equation will reduce to an algebraic equation. So in the second step, we have to solve the algebraic equation for y of s, where L of y of t is equal to y of s, and let y of s equal to f of s. Step 3, take inverse Laplace transform on both sides of y of s equal to f of s. That is, L inverse of y of s is equal to L inverse of f of s. That is, y is equal to f of t will be the required solution. Now, to solve these linear differential equations, we need to remember the formulae in Laplace transform of derivatives. So we have already learnt Laplace transform of derivatives, in which L of f dash of t is equal to s f of s minus f of 0. L of f double dash of t is equal to s square f of s minus f of 0 minus f dash of 0. Further, L of f triple dash of t is equal to s cube f of s minus s square f of 0 minus s f dash of 0 minus f double dash of 0. Now, the problems involve only the first order and second order derivatives in your syllabus. Third order derivatives are beyond the scope of your syllabus. So just for information, we need to understand that L of f triple dash of t is as mentioned here. Now let us go ahead with the problems in which we will solve differential equations using Laplace transform. So let us take the first problem. Solve y dash minus 5y minus e power 5x given y of 0 is equal to 2. So here we need to understand that the equation is a first order differential equation. So whenever a first order differential equation is given, there will be only one initial condition given in the question. Given a second order differential equation, there will be two initial conditions given in the question. So going ahead with this problem, the first step we need to take Laplace transform on both sides. By taking Laplace transform on both sides using linearity property, we get L of y dash minus 5L of y equal to L of e power 5x. So L of y dash, we have to relate it to L of f dash of t. So we know that L of f dash of t is sf of 0 minus sf of s minus f of 0. So here with respect to y, we are taking sf of s minus y of 0 minus 5 L of y. L of y is again y of s, or we can write f of s. That is equal to L of e power 5x. So Laplace transform of e power 5x is 1 by s minus 5. Having got this step, in the next step take common terms f of s. So having taken f of s within brackets, we are left with s minus 5 minus y of 0. Substitute for y of 0. Y of 0 is 2. On the right side we have 1 by s minus 5. Now in the next step, move this constant to the right side. Now take the LCM and solve. We will get 1 plus 2s minus 10 by s minus 5. So when we simplify 1 minus 10, it becomes minus 9. But however, we are going to proceed with the next step by writing it as 1 by s minus 5 plus 2s minus 10 by s minus 5. But on the left side, we have another s minus 5. When it is moved to the right, we get s minus 5 whole square in the denominator. So that is how we have 1 by s minus 5 whole square plus 2s minus 10 by s minus 5 whole square. In 2s minus 10, 2 is a common term, moved outside the bracket. That leaves us with s minus 5. So s minus 5 and s minus 5 in the denominator gets cancelled, and we are left with 2 by s minus 5. The other term is 1 by s minus 5 whole square, and that can be written as 1 by s minus 5 power 1 plus 1. And numerator can be written as 1 factorial, just writing it in the standard form. Therefore, now take L inverse on both sides. Taking L inverse on both sides, L inverse of f of s is nothing but y of s, y of x, that is equal to L inverse of 2 by s minus 5. So 2 is a constant, it can be moved outside the transform, and L inverse of 1 by s minus 5 is e power 5x plus L inverse of 1 factorial by s minus 5 power 1 plus 1. So usually we used to write t e power 5t. Here we see that on the right side it is a function of x. Therefore, solution will also be a function of x. So we have to write all the terms as a function of x. Thus we get the solution y equal to 2 e power 5x plus x e power 5x. Now going ahead with the next problem, which is a second order linear differential equation. So let us solve y double dash plus 9y equal to 25 e power 4t, given y of 0 is equal to 3 and y dash of 0 equal to 7. So you can observe here that for a second order linear differential equation, there are two initial conditions given in the problem. So given y double dash plus 9y equal to 25 e power 4t, firstly we have to take L on both sides. Taking L on both sides, we have L of y double dash plus 9y equal to 25 L of 4t, L of e power 4t. By using linearity property, L of y double dash plus 9 L of y is equal to 25 L of e power 4t. So for L of y double dash, we will be using the formula for L of f double dash of t. So in place of f of s, and wherever we have f, we are going to use y. So the formula is s square f of s minus f of 0 minus f dash of 0. All the f's replaced by y. We will get s square y of s minus s y of s minus y dash of 0 plus 9 y of s equal to 25 into L of e power 4t is 1 by s minus 4. Now we have to substitute for y of 0 and y dash of 0 from the initial conditions given. Having got this, we are going to substitute. That will give us s square y of s minus 3s minus 7 plus 9 y of s equal to 25 by s minus 4. Group all the y of s terms. So s square y of s plus 9 y of s is equal to 25 by s minus 4. Move the other terms to the right side. That will be 3s plus 7. When it goes to the other side, the sign changes and it becomes 3s plus 7. Thereby, on the left, take y of s common. That will give us y of s into s square plus 9 equal to 25 plus 3s plus 7 into s minus 4 whole divided by s minus 4. So taking LCM, we will get this step. Remove the brackets and simplify. That will give us 25 plus 3s square minus 12s plus 7s minus 28. Simplifying the coefficients, we will get 3s square minus 12s plus 7s is minus 5s. 25 minus 28 is minus 3 whole divided by s minus 4. Therefore, y of s is equal to 3s square minus 5s minus 3 by s minus 4, and this s square plus 9, when it is moved to the right, it goes to the denominator and it becomes s minus 4 into s square plus 9. Now we have to take Laplace transform. Step 2 is done. The third step is to take inverse Laplace transform. Before we take inverse Laplace transform, we should resolve the right hand side into partial fractions. Therefore, using the rules of partial fractions, we have 3s square minus 5s minus 3 by s minus 4 into s square plus 9. So s minus 4 is a non-repeated factor and factorizable. Therefore, a by s minus 4. S square plus 9, using rule 3 of partial fractions, s square plus 9 is non-factorizable Therefore, the numerator will be bs plus c. Now, on the left hand side, we have 3s square minus 5s minus 3 equal to a into s square plus 9 plus bs plus c into s minus 4, taking LCM. Now, we have to find the constants for a, b and c. So, put sc equal to 4, b and c gets eliminated and we can solve for a. Next, put sc equal to 0. We will get minus 3 equal to 9a minus 4c. So, minus 4c equal to minus 12 because a is 1. Hence, c is equal to 3. Next, equating the coefficients of s square, we will get a plus b equal to 3. A is 1, so b will be 3 minus 1 equal to 2. Substituting these values in equations 1 and 2, the fraction now reduces to 1 by s minus 4 plus 2s plus 3 by s square plus 9. Separating the terms, y of s on the left hand side is equal to, on the right hand side we have 1 by s minus 4 plus 2 into s by s square plus 9 plus 3 by s square plus 9. In the last step, we have to take inverse on both sides. L inverse of y of s is equal to L inverse of 1 by s minus 4 plus 2 L inverse of s by s square plus 9 plus 3 to be moved outside the transform. So, plus 3 L inverse of 1 by s square plus 9. Therefore, L inverse of y of s is nothing but y. And we see that in the beginning of the question on the right hand side, we were given a function of t. Therefore, solution should also be written as a function of t. Hence, y is equal to e power 4t plus 2 into inverse of this function is cos 3t plus 3 sin 3t. Okay, so 3 sin 3t, but we have to multiply and divide by 3 here. So, it will give us sin 3t. Thank you.